Okay, good day. This is Math 140 College Algebra. I'm Professor McCully, and this is lesson 2.4, Nonlinear Piecewise Functions. Let's get right to it. Today we're going to graph nonlinear type piecewise functions, and we're going to evaluate and use the greatest integer function. So let's talk about that greatest integer function, and the greatest integer function the greatest integer that is less than or equal to x. So we need to review what an integer is. An integer is just a positive or negative counting number. So 1, 2, 3, 4, 5, and so on. Also 0, also -1, -2, -3, -4, and so on. So this thing says that they want the greatest integer that is less than or equal to whatever number is inside these kind of funkadoo brackets here. And so the greatest integer that is less than or equal to 2, now 2 is an integer, so the one that is less than or equal to 2 is 2. All right, the greatest integer that is less than or equal to 2.4, 2.4 is not an integer, so it can't be equal to that number, but the greatest integer that is less than 2.4 is also 2. The greatest integer that is less than or equal to 2.9, similarly to 2.4, is 2. And this is the one that always fools people up. The greatest integer that is less than or equal to -2.9 is actually -3. Now let's talk about why that is. So the first thing that we want to do is grab ourselves just a graph here. And so let's talk about the 2's here, all right? So the greatest integer, so we're graphing f of x, and the way that I graph it is I usually put a double bar here. Oops, give me back my pen. I usually put a double bar right there to indicate the greatest integer function. So at 2 we get, oops, let's do it right. At 2 we got 2. At 2.5, we got 2, and at 2.9, we got 2. And all of these values in between will also give us 2 right up until we get to 3. Now at 3, we get an integer. 3 is an integer, so it's going to move up to here. So I'm going to get this thing kind of like a step function. So it's going to have these little open circles at the integers where it's going to go up. And then let's talk about that -2.9. Well, if I follow this down backwards the other way, I'll get a graph that looks like this. And let's plus one more. And so every value that is negative, like -2.5, well, -2.5 is going to round down to -3, and I'm going to get a graph that looks like this. Now, I am going to show a graphing calculator version of this, but notice that these have points at the integer endpoints on the low end, and they have open circles on the right-hand side, because at 5, it's going to round up a little bit. Now the graphing calculator will do the greatest integer function. Let's clear this out. And so if you go to math and you go over to number 5 is integer. So if I hit y equals, I clear out this stuff. I hit the math button, I go over to number, and I get integer 5, and I plug in an x, and I go, just in case we didn't see it from the last one, we'll do zoom standard. We'll see that step function. Now the problem with graphing calculator is because it's graphing pixels and not necessarily everything that you might see, you'll notice there is no open circle on the right hand side. There is no closed dot on the left hand side. So you have to know that when you're doing your graphs for quizzes and tests. Okay, let's talk about some piecewise functions. And a piecewise function, let's just do a simple one. F of x is equal to, we'll just do 3 pieces. We'll say x plus 2 for values of x that are greater, or let's do less than to begin with. For values of x that are less than, let's say, -2. Let's say it'll be 4 for values of x between -2 less than or equal to x less than or equal to 3. And then we'll do -x for values of x that are greater than 3. Now, what is that graph going to look like? Well, just real quick, for values of x that are less than -2, we will have a graph that has a slope of 1 and a y-intercept of 2. So if it actually got there, it won't. And since we have this less than symbol, we'll have an open circle. So just real quick, we're going to make a quick little XY table here. It's going to be a linear graph. So -2 will plug in. -2 plus 2 is 0. It doesn't include that. So at -2, we get 0. This is unincluded. So we'll have an open circle there. If I plugged in -3, -3 plus 2 is -1. And just for good measure, -4. -4 plus 2 is -2. So I have this. And so that first piece is going to look like this. And then it's 4. Well, y equals 4 is a horizontal line. And so from -2 to 3, we're going to have a horizontal line at 4. So we'll have that point right there, and we'll have that point right there. And we'll just connect the dots with a line. And then for the last piece here, starts at 3. If I do 3 and I make it negative, I'll have -3. So at 3, I'll have this open circle at -3. If I plug in 4, we'll make it negative. That's -4. If it's 5, we'll make it -5. And we could have made a table of values for this set too, but it's fairly simple. Just figured I'd do that real quick. So that's my piecewise function for that particular one. Now, nonlinear piecewise functions are going to have, it's going to be set up the same way, except the function parts are nonlinear. So let's take a look at a couple examples of nonlinear piecewise functions. So we have this thing right here. And this thing has 3 pieces, just like the last one. It even has 4, like the one I did. That part's going to be linear. But I have 2 nonlinear equations. This one's a parabola, and that one is also a parabola. So if I'm going to set this particular one up, and hopefully everything fits inside this window here. So for values of x that are, and you know what? Let's since it changes at 0 and 2. Here's what I'm going to do. I'm going to take this thing. Come on, let me do it. I'm going to move. Oops, I don't want that. I want this off. Let's ungraph that. Let's see if it'll let me move it. Will you let me move it? Give me a hand. There we go. All right. Now we're cooking with gas. 2 squared is going to be bigger than 2. So maybe I might want to do this. Pull it down just a little bit. That looks good. Okay. So for values of x that are less than 0, I'm using this first rule. So again, just real quick, table of values. X0, when I plug in 0, 0 squared is 0. -4 is going to be -4, so I'll have a point right here. And then I need to pick other values that are less than -4, or less than 0, excuse me. I don't know why I said -4. Less than 0, because we're looking at this x less than 0 expression. So I'll pick -1. -1 squared is 1. -4 will be -3. -2. -2 squared is 4. 4 minus 4 is 0. So I'll have a point here, and I'll have a point here. And we know that that's a parabola. So it's going to have a shape that looks like that. It's going to be a linear equation from values of x. Ooh, made a mistake. Didn't see it. Hopefully you guys did. Less than 0. That should be an open circle right there at the end. So let's make sure we get that open circle there. Alrighty. Now, because I have the less than or equal to symbol, I'm going to have at 0, I'm going to have a closed dot at 4. So I have a closed dot right there. And then this f of x equal to 4 is going to be a horizontal line from 0 to 2. And because of this less than symbol, I'll have an open circle at 2. And then we just need a line from there to there. And then this last one, x squared plus 1. And so at 2, 2 squared is 4, plus 1 is 5. So I have an open, or actually I have a closed dot, again, because the greater than or equal to symbol, we are including 2. And then when I pick 3, and so for this one, let's just do another real quick little x, y, and I think I should have made that a y as well while I'm thinking about it. So everything's perfect. And let's see here. So at 2, I have an open circle that's going to be 5. And then at 3, 3 squared is 9 plus 1 is going to be 3 squared is 9 plus 1 will be 10. So that's actually off the chart. So somewhere up here, I'm going to have that. And so it's going to look like that. And so we'll say that this line went up here to 10, and that was the point, and everything looks good. All right, let's graph this last function here. And so this last one here is graph the greatest integer with a -3. And so this graph is just going to shift everything down 3 units. So here's what I'm going to do. I'm going to go back up to this one here. So we're going to talk about transformations in a little bit. But if I said g of x was equal to the greatest integer function, x, and then -3, it's going to look exactly like this particular one here that we did before. But we're going to subtract 3 from every value. So let's just start with there. When I plug in 0, the greatest integer less than or equal to 0 is 0. -3 would give me a dot right there. I did a half. The greatest integer less than or equal to half is 0. -3 would also be -3. And then when I get to 1, the greatest integer less than or equal to 1 is 1. -3 would be -2. So I've got a dot there. So what's going to end up happening is I'm going to have this open circle there, and I'm going to have this step feature that's going to look exactly the same as that original one, except each step is this 3 units lower than the one before it. And we'll just do one more over there to get us together. All right there, folks, that's all I got for today. That one should be a pretty short one. So our Marvel fun fact of the day: for both instances of Baby Groot dancing in Guardians of the Galaxy, at the end credit scene in Volume 1 and at the beginning in Volume 2, the director James Gunn performed a dance which was later digitized and shrunk for Baby Groot in the movie. That's all I got for today, folks. Have a good day. Bye.